parteneriatul cu Intel a început pentru Magwai în anul 2000, din câte înțeleg, deci la trecerea în noul mileniu, și prezentarea va avea, cum puteți bănui, două părți, una axată pe data center și una pe client. The stage is yours.
Thank you. Good morning, everyone. So yeah, we are going to present smart computing for smart businesses. I see only smart people here today, so I think we have the right content for the right audience. My name is Lukasz Chrzanowski, industry technical sales specialist, working daily with partners across EMEA region, mostly in data center, and I'm accompanied today by my colleague Wojciech, Bosek.
So, but it's better with the microphone.
So yeah, we have quite packed agenda for today, a lot of topics to talk about, and I actually had too many slides, so I had to remove the slide with agenda, to be honest. But actually this one works as well as the agenda slide, because we are going to touch most of the topics that you can see on the slide today. So we are surrounded by AI in many different forms, and we can see here the circle of how the classic AI implementation is being done. Yeah? So we are having the data preparation, model creation, training, and then deployment using cloud environment, edge, or client. So AI is everywhere, and we are powering this AI revolution by offering our hardware and software solution as well. So in the center here you see the hardware elements that we are providing on client segment, on cloud segment, and edge, which is kind of in between because it takes advantage of both client and cloud technologies. And this is all powered by a really nice set of software toolkit under the umbrella of One API. So we are going to talk quite a lot about One API as well today.
Yeah, and what is important, all those software are mainly Intel, or Intel is participating in creating this software solution. So we are not offering only hardware, and you have to remember that this software is done by thousands of our programming guys. Lots of them are sitting in Gdańsk, where Lukasz is working. Exactly. There are over 3,000 people already there, and they are doing lots of those applications.
Yes, and they are developing all the software, like from the microcode level up to the drivers, so full stack. So how we are approaching this? So some time ago we announced our ambitious plan to deliver 5 manufacturing nodes in 4 years, and so far we are doing really great, to be honest. So we have Intel 7 ready in high volume. We have Intel 4 ramping today. Actually on the 14th of December we are going to launch Meteor Lake and Emerald Rapids families. Meteor Lake is going to be based on Intel 4, and the rest of the processes are on track. So we are steadily delivering what we promised, basically. And this is the base for our upcoming product lineup. And starting with Meteor Lake that I mentioned already, launching on December 14th. We don't have time to talk about all the features of Meteor Lake, so I decided to talk about the features I love. So
yeah, most important feature, it's not going to be desktop processor, it's going to be mobile processor only. So it's going to be only on notebooks and mobile devices like Nux, which is Asus right now, but nevertheless, all those devices that use mobile solution, it's going to be with Meteor Lake. There will be no desktop version.
Yeah, on desktop we recently launched the 14th gen, and I read yesterday that our colleagues from Asus managed to drive it up to 9.04 gigahertz, so breaking the record again. So that's also impressive in the desktop space. In the mobile space, Meteor Lake will launch at the end of this year. So this is the architectural marvel of IT, to be honest. So it implements a lot of different features, PCIe Gen 5, Foveros 3D packaging. We implemented also Thunderbolt 4 and Wi-Fi 7 support. And we have a lot of new features and technologies. And I personally love 3 of those mostly. So first of them is 3D performance hybrid architecture. You probably know the hybrid architecture based on the performance core and efficient cores. They are visible here at the bottom. But what we are introducing in Meteor Lake is additional low power efficient core that is sitting on a different tile in the processor. So we have the compute tile with E cores and P cores, but we also have the SoC tile, which is a separate tile. And the idea behind it is that you can actually scale the performance and efficiency and power consumption really, really well, because the baseline, the default option is that we try to contain the workload on the SoC tile, on this low power efficient core, without even powering up the compute tile. Yeah? So this saves a lot of energy and helps to drive your battery life. And if the low power efficient core isn't enough, we power up the compute tile, first starting with efficient cores, and if it's not enough still, we power up the performance core. So this really helps to drive efficiency, performance, and battery life in the mobile devices. So that's the first thing that I love about Meteor Lake. And second thing I love is the integrated NPU. Does anyone want to guess what the acronym stands for, NPU? So, yeah, neural processing unit, exactly. So I would compare it to the situation like 20 years ago when you could have a regular PC, but if you wanted to play games, you had to have additional 3D accelerator, yeah, for gaming. And NPU works in a similar way, but is dedicated for AI workloads. And you might think, okay, AI is not something that we use every day, probably, but actually we are using this every day. Because if you are joining Microsoft Teams calls, for example, like I join them daily, yeah, you can blur your background, you can filter out the noise from your microphone to, not to transmit, barking dog or loud children or your neighbors drilling in the walls, yeah. So all those features use and can use AI-based algorithms. And having an NPU integrated in the processor first gives you an ability to offload those tasks from your main CPU, but even more important, it opens a gate for further improvements and some exciting features that we can experience in the nearest future. So let's say today Microsoft Teams gives you an ability to have live caption of what you're saying. Yeah? So I'm saying something and there are subtitles generated in real time. But going further, with dedicated NPU in the processor, you could potentially have live translation of your Teams call, yeah, and many other exciting stuff that you can.
Most important thing, when this working, your CPU power is fully available. So this is additional engine that offload your processor power. So all those functions that Lukasz was talking about, right now is done by CPU power. But in the future, it's going to be done by this, and you will still have your computer power for something else.
Exactly. And then the third thing I love about Meteor Lake is the new generation of our XE low-power graphics. So as you can see here, comparing gen over gen, we are delivering roughly double the performance in each generation. Yeah? So XE LPG that you will find in Meteor Lake is based on XE HPG, so high performance gaming, but just in the lower power envelope. So same principle, same architecture, but bringing it down to the low power envelope to deliver the maximum efficiency. So performance per watt, really, really great, but overall performance comparing to the previous gens as well, twice the performance of XE low power that we had before. And next thing that I love, not only about Meteor Lake, but our client solutions in general, is the vPro platform. So smart businesses, if smart business is looking for a device, the business client device, you should look for a vPro badge, actually. And there is a lot of reasons why. So first, performance, security, and stability. But what I really, really like about vPro is manageability part here. And especially now when we have hybrid workers, home office workers, now we don't typically have a few offices with 100 employees in each office. Yeah, we have hundreds of offices with one employee per office. In their home office, in a restaurant, they can work whenever they want, right? And IT management is tricky in this scenario. vPro with cloud-based manageability using, for example, Intel EMEA, Endpoint Management Assistant, gives you full out-of-band management features. So in a scenario where, for example, your user deletes System32 folder and Windows wouldn't boot, yeah, you can still potentially save this device remotely. You can upload the Windows ISO image from your server, reinstall the complete machine, and user can still working without getting out of home, even if it's located, 500 kilometers from your IT admin.
Or even sometimes start in the safe mode because the user cannot do it and save the system. So everything is here possible.
Yeah, exactly. And majority of issues are related to the software on various levels. Yeah, so rarely you have burned down motherboard, or a graphic. So all of those features potentially
you can enter the
fix.
BIOS, change the settings. If there's a new feature that you want to add or something like that, it's possible. Update the updates if user cannot do it. Everything is there.
Exactly. Updates is another way of using vPro. So you can schedule updates to be done, let's say, over the night. Yeah. So you can wake up the device during the night, install all the updates, and in the morning, when your employees just want to start to work, they don't need to wait for the system to reboot, to install all the updates, etc. Yeah. So it really drives efficiency and productivity in the client space. And also in the client space, we have the Intel Arc graphics with a couple of segments. So today we are going to focus mostly on the business side, so professional graphics, but we have the whole lineup of Arc products. So Arc graphics for desktops, A700, A500 products, Arc graphics for laptops, which is basically the same thing, but in smaller form factor and lower power envelope. Yeah? And then we have Arc professional graphics dedicated for businesses, for creators, for people that render videos or work with CAD programs to design things, yeah, and they need a lot of processing powers from the graphics as well. And last but not least, we have also Arc GPU for the edge in the form factor of a chip that you can integrate in whatever form factor you'd like to have your device. Yeah, so that's another way of using Arc GPUs. So focusing on professional graphics, we have a nice lineup of products, starting with A40 through A50, A60, and then Arc Pro graphics for laptops that audience can integrate into their laptop motherboards. The benefit that I really like about professional graphics for Arc is that first we have full support of the latest technology. So full AV1 support on both encode and decode side, but even more important, a lot of software validation. So you can see some logos here, Handbrake, Premiere Pro, DaVinci, but there are more. There is Blender, there are other CAD-related programs that really take advantage of capabilities of Arc graphics. And this is one of the reasons to use it, yeah? And of course, we also have other technologies like ray tracing, for example, yeah, which is getting more and more popular now, also in professional design environment. And that would wrap up the client portion of our today presentation. So smart solutions for client, and now we are entering into the smart solutions for smart data centers. And I would like to start with explanation of how we design data center solutions right now. Yeah? So before, Intel used to think about what cool technology we can make and just put it to the market, yeah, and expect customers to use it. And now our approach is slightly different. So now we start with the workloads that our customers are using. And now the most popular, the most common are storage, 5G network, HPC, AI, obviously. Yeah. So first we think what our customers do. And then we design the technology that can support those workloads. So starting with CPU cores, obviously, because this is our main power, delivering the best possible CPU cores. But we added built-in accelerators on top of that, exactly to support those focused workloads that we have in mind while developing a modern data center solution. And that is the hardware portion, but hardware wouldn't work without the nice software stack. Yeah. So that's why we are also launching open software tools that help developers to get the most out of our hardware, and this is based under the envelope of one API and dedicated tools for several workloads actually. So AI is one of them, but we have also dedicated toolkits for specific workloads, and we will talk about those later on today as well. And those things drive the results here. So higher performance, increased efficiency, and optimal TCO. So the things that smart businesses love, yeah, efficiency, saving money, and having the best possible performance. So starting with our recent Xeon processors, 4th generation Xeon scalable processors, just key features here, full scalability, up to 8 sockets, up to 60 cores per single processors, PCIe Gen 5, DDR5, most built-in accelerators of any CPU available on the market. And this is quite important. We will touch this topic in more details later on today.
Yeah, you have a demo in the demo section with the 4th gen processors. You can look at it at the break and see all those features working.
Oh, good to hear that. I didn't know. UPI that enables faster communication between the sockets and CXL and hardware-enhanced security. So obviously, security is also a key feature of most of the data center platforms. And I mentioned most built-in accelerators in any possible available CPU on the market. You can see them listed there. Obviously, we are not going to go through all of those. We grouped them into segments. So again, focusing on specific workloads, specific stuff that customers are doing in their data centers. Yeah? So we have accelerators for AI workloads, for security, for HPC network analytics and storage. And as you can see, we are not long.
What is important that those accelerators, they are working like this NPU that we mentioned before. If those accelerators are working, you still have a power of the CPU. Of course, sometimes the workload need the power of the CPU and accelerator, but with accelerator, we don't use the full power of the CPU. We don't use the full power from the source, and the efficiency of the server is much better. So it takes less power from the core.
Yeah, exactly. So, like if you have a restaurant, you can have one guy getting orders, preparing the meal, and serving the meal. But with accelerators, we actually can divide those tools and assign the cooking to the specialized cook in the kitchen. So this is kind of how accelerators work, freeing the resources from the CPU as well.
And to tell you the truth, one of the features, for example, QuickSync, we had a special card. 8950, I think that was the card, which was like a graphic card, big card that did only encryption and decryption. And right now the feature is included in the CPU. So this is not the small things.
Yeah, exactly. So we had the quick assist technology card, and this was an add-on PCIe card that consumed your PCIe slot on the server. Now it is integrated into the CPU, and I think on the next slide we are showing how much more performance you're getting while using QAT. But how to use it actually? So we have a lot of those accelerators integrated in the CPU. Here we see a few of them only. So dynamic load balancer, advanced matrix extensions, quick assist technology, data streaming accelerator, and Intel in-memory analytics accelerator. You might think, okay, it's hard to use because I don't know how to use them, yeah? But we provide a lot of software tools that help you take advantage of that. And you don't need to have a really deep, developer's knowledge on how to navigate through all those complex libraries. We have one API-based toolkit. At the bottom here, you can see that this is the default set of tools. And it also includes optimizing tools like vTune Profiler. So this helps you to identify the bottlenecks in the workload and suggests the best way of solving that. Yeah? So let's say your workload includes compression, yeah, and so up until now you have been doing this using the CPU resources. Well, now using our libraries, our sample codes, you can extract this part of workload and assign it to QAT that you have integrated on the processor. So this would help to dramatically drive up the performance that you get out of the same processor. Yeah? So without a lot of modification, with just a few lines of code modification, you can drive great performance. And the base toolkit is just the default set of tools that we are providing. But as you can see at the bottom here, we have dedicated toolkits for specific workloads. So if you are running HPC workloads, we have HPC toolkit. Same for rendering, media, streaming, etc. So rendering toolkit is very helpful for that. And for the visual inference, we have AI analytics paired with OpenVINO that really helps to drive the efficiency.
And moreover, all those toolkits are free. If you want the support, you have to pay, of course. But all those toolkits are free. You can download it from the site and use it with our solutions. And moreover, if you use one API, it will work not only with our products. It will work with all the products that are on the market, like, I don't know, NVIDIA, competitive solution from AMD, their GPU cards or whatever. Of course, it will work best with Intel, yeah? But nevertheless, it's going to work. It's not closed architecture.
Yeah, some of the features will work only on Intel because only in Intel you can have integrated accelerators like those one. Yeah, so, but generally speaking, it would work on any x86 platform. And additional benefit of one API is that it works across basically all the hardware portfolio that we have. So if you have a workload running on Xeon only, yeah, you have your piece of code, it runs great. If you want to scale it up and, for example, add a graphics card to your hardware setup or a Gaudi accelerator or FPGA, yeah, you don't need to rewrite the code because one API tools give you the ability and simple ways of just enabling and switching the switches in your software to run specific parts on the code on specific piece of hardware, and that drives additional efficiency in the project development time because you don't need to spend a lot of time rewriting the code. You are using simple tools included in one API to drive this scalability. And recently we announced that we launched the Intel Developer Cloud, so cloud.intel.com. This is the place where you can actually kind of touch those devices because you can build your remote instance based on Xeon or Xeon and GPU or Xeon and Gaudi and test your software in the actual environment. Yeah? So you don't need to buy nodes, you don't need to ask for any samples and build your own node. You get to cloud.intel.com, you select what kind of node you want to build, what kind of instance you want to use, and then you can deploy your software and check, and then decide what hardware setup is the most optimal for your specific case.
And you can do it from your home, from your laptop, with no problems, because it's available to all of you.
Exactly, and you don't have very noisy server blasting sound to your ears, and development is easier. Okay, so I mentioned accelerators, but what is the actual benefit of using accelerators? So here we are comparing 4th gen Xeon with 3rd gen Xeon in specific cases. Yeah, so on the general purpose computing, on average, we see 53% performance gain, gen over gen. But if we look at the specific workloads, you can see that you can double the performance in your network environment. You can triple the performance in data analytics, and you can drive up to 10 times better inference and training performance using AMX in 4th gen. And also we have the dedicated Xeon CPU Max series with built-in HBM memory on the package that is really great for HPC scenarios.
64 gigs, so it can run even without any memory. You can run this CPU, just putting the CPU into the system and run it from the integrated memory that is on board.
Yeah, exactly. If your workload fits into 64 gigs of memory per socket, then you don't need additional RAM to be installed at all. And still you get up to 3.7 better performance on memory-bound workloads. So how does it translate to the actual results? Because this was on average. Here you can see how it behaves in the certain workloads. So the baseline here, this white lane, is the performance of 4th gen Xeon with accelerators off. So you're just using the CPU power, the main core power, yeah, without accelerator. And then those bars show you how much you're getting out of accelerators when you turn them on. Yeah. So, for example, if you enable AVX512 in LeanPack, you get 61% better results. In AI, there is almost the biggest difference, because if you turn on the AMX, the Advanced Matrix Extensions, you can see that we're measuring ResNet 50 here. Yeah. So you can get, almost 10 times better result on batch image recognition on ResNet 50.
So lots of interference or lots of data gathering and things like that you can run on your current structure with Xeon 4th generation, not needing GPU even.
Exactly, and we mentioned quick assist, and here the last bar here on the right shows the compression performance. So we actually had to cut the chart to fit, this 28 times better performance on compression. So imagine how much time you can save by offloading, the compression to QAT instead of running it on the CPU itself. And how does it translate to business actually, and the money that business want to make? So here we are comparing 50 nodes based on the 3rd gen Xeon. And we selected a few workloads, took the same performance goals, let's say. Yeah. So the goal here was to get the roughly the same performance level with 4th gen and compare it to 50
the
servers
same pricing
on 3rd
level,
gen.
the same SKUs.
Yeah, exactly. And it turns out that because of you can use accelerators which drive up the performance, instead of using 50 servers on Ice Lake, you can use 15, 17, 18 servers depending on the workloads. Yeah? So you can really reduce the number of nodes while still keeping the same performance goals. And this naturally translates to less space that you need to use, lower energy bills that you pay, and in the perspective of 4 years, you can see at the bottom here that you can save more than $1 million in the 50 node scale, yeah, just jumping from 3rd gen to 4th gen, and this is actually assuming the electricity cost from a few months from before, yeah, and probably it's going to get even higher going further. And a little bit about security. So with 5th gen of Xeon, which we are going to mention as well, we are going to introduce a new feature called trusted domain extensions here. And this is one of the options of securing your data center depending on your needs. So basically, it comes down to what part of data center you own and who do you trust in your data center environment. Starting with the bottom, if you own the software, the app, and your app is running in some external environment, you can use Software Guard extension to secure a portion of the memory in which your app is running. Yeah? So let's say you have very sensitive data and you don't trust your cloud service provider, yeah? Or you don't trust the server, the owner of the server that you're using to process that data. So you can secure this portion of data in the secure enclave in the memory using SGX. TDX.
And we are the only one that has this feature. I mean, everybody can have access restriction on virtualizer, on the node, on the virtualizer, on the operating system. This can be done, but nobody goes as deep as the application mode. So application mode is the most secured feature with SGX solution.
Yeah, exactly. And TDX is a level up extension of SGX capability. So with TDX, we assume that you own your VM, yeah? So everything related to your VM is secured. You don't trust other VMs, you don't trust the hypervisor. So that's the next level. And then level up, we have total memory encryption, where you can encrypt the whole memory on the server. And this actually gives you scalability and flexibility, because depending if you are an owner of an app or cloud service providers, you can decide how do you want to protect the data and what level of trust you have within your data center space. Yeah? So TDX was like the missing bit that we are introducing in the 5th gen of Xeon. And 5th gen of Xeon is going to launch also on December 14, codenamed Emerald Rapids. And just to touch on the whole roadmap that we have for the data center, next families will be based on performance cores and efficient cores. So we are going to separate a little bit our data center roadmap. Emerald Rapids will be still the old school kind of powerful core CPU. Next one, Sierra Forest, will be 1st generation on efficient cores with up to 288 cores. So that's a big jump in terms of the core count. And then we are going to have Granite Rapids based on P-core and Clearwater Forest based on E-core. So that's a short snapshot on our roadmap. And while CPUs are great for general purpose acceleration and many different tasks, if you want to go into specific scenarios, especially in AI, you might want to use some additional acceleration. Yeah, so CPUs are great, but we also have data center GPUs, and we also have Gaudi, which we're going to talk about now. So starting with GPUs, we have two segments, two product lines for data center GPUs. First is the Flex series, and we have two products there. So first one is Flex series 140, a half-height 75 watts PCIe card. Important thing, 4 media engines and 16 ray tracing units and 16 Xe cores. This one is based on the Xe HPG graphics, and it's really nice to drive scenarios when you want to get out to the world, let's say, with a lot of streams. So cloud gaming, VDI, especially in VDI, this is really nice product because comparing to NVIDIA, you don't have licensing cost assigned to your VDI deployment. As we mentioned before, one API and other tools helps you to drive your software on the cards. If you're using VDI on Flex cards, you don't have annual licensing costs that you typically have with your NVIDIA deployment.
This card has 4 media engines because actually this card is connected with two cards connected together, 2 8-core cards, and that's why we have media delivery on the level of 30 streams. The next card is more for 170 card is more for calculations and cloud gaming. It's more efficient because it has 32 cores. Yeah, so.
Yeah, exactly. So this 140 has like 2 GPU chips on a single card. That's why we have 4 media engines, and we can drive a lot of streams. The next one, 170 series, you can notice that it has twice the power, 150 watts, but it's one bigger GPU chip. So it has 2 media engines, but more Xe cores. So we have 32 Xe cores, 32 ray tracing units, 2 media engines. So if your workload is more demanding from the computing side, but you don't need so many streams to get out, 170 would be better because it has more computing horsepower inside, yeah, to process all the graphics that you have to process. And 140 is better to process, but getting out to a lot of different users. And we also have the Max series data center graphics. This is based on a different architecture. So Flex series is based on the Xe HPG architecture. This one is based on Xe HPC. And the difference is that the Xe cores that you see here are bigger. They have bigger registers. They are more designed to drive HPC workloads with bigger data sets, basically. Yeah. So we have up to 128 Xe cores, many different form factors. So PCIe card,
2 form factors.
OEM.
2 form factors.
Yeah, but we also can build the whole node, yeah, and deliver this whole, eight times graphics.
This reference to OEM version, and it's built depend on the producer. I mean, you cannot buy it separately. It's soldered down on the board, and you can have 4 solution from MyTAC right now and HP. There is a special node that has a 6, but it's used only on one solution from Cray. And Supermicro and few others, they are using 8 OEM on one board solution together with 2 Xeons. So you can have up to 8 GPUs on site. And of course you have PCIe version, which is, because this one is 1550, the number of the SKU, and the second SKU is 1100, PCI Express card. It has 56 cores and using only 300 watt power. This one, each one 600 watt power TDP.
Yeah, so comparing to Flex that had 150, here we have up to 600 watts. You can imagine what kind of workloads are good fit for Max series.
This is HPC and artificial intelligence workloads mainly.
Exactly, and we are using this Max series in our Aurora supercomputer partnerships with HPE that is currently being finished. And you can check out some videos on YouTube. There are some tours on inside of the Aurora, how it's built. So really impressive stuff.
By the way, almost 64,000 GPUs is in there. So it's the biggest GPU installation in the world right now.
Exactly. And again, to highlight the value of one API, we mentioned Flex and Max series cards. You can run the software on those cards paired with Xeon using different one API toolkits. So for the cards itself, AI analytics, for example, one API rendering toolkit, those would be a nice fit to workloads that require external graphic
This is
cards.
actually from the site, so you can log into the site and you will have this access, you can download all those things. So this is screen from our
Exactly,
side.
and we have a lot of resources that are useful for developers. You know how to start, how to set up your environment, sample codes, libraries, etc. So really nice.
Step by step, yeah.
Yeah. Developer.intel.com. And now the Gaudi. So
Last but not least.
yeah, even not last, because we have also a bit about Ethernet at the very end. But just to mention the Gaudi, we still have 5 minutes, so we should be able to finalize that as well. Gaudi. So Gaudi is targeted for deep learning, inference, and training acceleration. Now we are at the Gaudi 2 stage, available via our partners. Going further, we are going to launch Gaudi 3 and then the one based on Falcon Shores. But today we are offering Gaudi 2, which already delivers really, really nice results. So this is how it looks like. We had a very similar image at the beginning with NVIDIA A100. Gaudi, as you can see, it looks fairly similar. Based on 7 nanometer process technology, we have a couple of Gaudi chips on this card as well. But how does it translate to the actual performance? So just one slide with the measurement that we did. There are more. So if you Google Hugging Face Gaudi, we have the latest results with Hugging Face AI results, and they are really impressive. Here we are comparing the GPT server and offline output, and we are comparing Gaudi with H100 and A100.
This is very important because this is the only workload that we have right now in FP8. And comparison with H100 is almost head-to-head. Of course, a little bit higher from H100 due to optimization and etc. But nevertheless, this is GPT-J. And I think on the second slide there will be another comparison, because if we compare right now, if we are looking at the comparison from competition, if we are looking on the competition comparison, they don't compare FP8 workloads with us. And right now we did it, and this is the FP8 workload. So we are much far better than A100 and go almost on par with H100, and we are much cheaper than their solution. So please go on this cloud site and test it. And if you want to test it, go to Magwai, guys. We can deliver the system or access to the dev cloud for all of you to test the Gaudi solution.
Exactly, and the additional benefit is that we are alternative suppliers. So in scenarios where supply is not really good, there is an option of getting an Intel board. And yeah, just to finalize, 2 minutes left, so a quick word on Ethernet solution. Our latest family, 800 series with up to 100 GB, single port, dual port, quad port, depending on your needs, with a variety of connectors, SFP optics.
Very
SFP
important
optics.
thing, we have quad port cards in 25 gig area. This is not very common on the market, but if you need high density on the quad port card, you can do it easily with Intel because we have it. And availability, I know that there was a problems with availability to all producers. We have right now full stock, and if you want to order any of our cards, especially 800 series, there is no problem to order them, and we are delivering quite fast.
Exactly. And again, one thing I love about Ethernet, you can split your Ethernet card into up to 8 10 GB. So if you take a 100 GB card, you can speed it up to 10 GB. Well, not virtual cards, let's say, yeah, with their own MAC address, etc. So you don't need a switch for that. So you have 6 possible configurations here, and you can have more flexibility in.
And you don't have to use it on the switch. You just do it with the cable, with no problems. So I know that other brands, they can do it with the switch functions and options on the switch. But in here, no, you just use it with the cable and it's done.
Yeah, you just have a 1 to 8 cable and you plug 1 and 2 to one end, and then you have 8 separate cables on the other end. And nice message for the end of our presentations. We have the promotions for 800 series cards. So if you ask for a quote of those of those models, it will be lower than you expect.
To tell you the truth, the pricing of the 25 gig cards right now is comparable with 10 gig. So if you are planning the infrastructure, of course the 25 gig card will work in 10 gigabit switch as a 10 gigabit card. If you upgrade the switch in the future, you will have 25 gig already. So if you are planning buying of the networking cards with the servers or with the workstations, just go ahead with 25 gig. It will work like a normal 10 gig card right now with the switching you have, but in the future you can upgrade it very easily. And of course we have a promotion on optics. I know that sometimes you are using some China optics and etc. But the pricing is really aggressive right now from our optics, and you have guarantee that this is a good product and a good quality product. And to tell you the truth, if you compare Chinese better things from China, not the cheapest one, we are on par with the pricing.
And that's it from our side. So thank you very much for your attention.
Thank you.
Have a nice day.
Thank you, guys. Thank you, Lukasz. Thank you.